Okay, so one thing to consider is 25 patients came to a chiropractor. So 25 people came to a doctor expecting to get better. Okay, so if he really wanted to see if he did anything to the patients, what he could do is he could have someone else come in. Sounds kind of extreme, but maybe have an actor come in and pretend to be a doctor and not know. Again, this sounds kind of cruel to say it like this, but not know what they're doing and see if the people who got the real chiropractor versus the fake chiropractor would actually be able to tell a difference. Now, I believe they're breaking several laws in doing that. I don't think you can pretend to be a doctor and do that. But what he could also do is he could perform a specific treatment, a specific maneuver on certain patients and then a different maneuver on other patients and see if the maneuver itself made a difference. Okay. A new drug for a type of attention deficit disorder is supposed to make the affected children less disruptive. Randomly selected children suffering from the disorder are divided into treatment and control groups. Those in the control groups receive a placebo that looks like the real drug. The experiment is single-blinded. Experimenters interview the children one-on-one to decide if they become more polite. Okay, so is there any part of that experiment that kind of jumps at you like, well, that might have impacted the data? They separated the kids out. They gave them real drug versus fake drug, so that's great. The problem is that's only single-blinded. So if I know the person I'm talking to didn't get the drug versus the one that did, I might act a little differently. I might phrase my questions a little differently, or I might respond differently to that particular person simply knowing whether or not they did or did not receive the medicine. It's kind of like if I know they didn't get the medicine and I want the medicine to be effective, when I'm talking to that person, in the back of my head I'm thinking, well, they didn't get the medicine. I'm not really going to take them seriously. So if they want to improve the results of their study, then they'd want to actually do a double-blinded experiment on that versus just single-blind. Okay, for each of the following questions, what type of statistical study is most likely to lead to an answer? What is the average income of stockbrokers? So, if I would like to know how much money stockbrokers make, I could do what? Well, I could just interview a bunch, and I wouldn't have to do an experiment. I could just do a observational study. So an observational I could just ask a bunch of stockbrokers and see how much money they made. Do seatbelts save lives? Could do an experiment. Probably should do an experiment. The question is, who should I do the experiment on? I don't think it's ethical to do it on actual people. So I could do an experiment on maybe a crash test dummy. I could also do the case control study. So in the case control study, I ask people after the fact if they wore their seatbelt or not. So I might look at accidents. So I might, talk to 1,000 people, and in that 1,000 people, there'd be a certain percent that had an accident. So I could ask of those that were in the accident if their seatbelt was on or not. Or if I knew a death was involved, I could go look at if there's evidence that the seatbelt was on the victim or not, and not actually do an experiment, because that would not be ethical at all. Can lifting weights improve runners' times in a 10-kilometer race? We can do an experiment with that. We could, Let's see, so we could break up two groups of runners that are similar abilities, and we could have one of them attend a weightlifting program and the other one not, and then after the weightlifting program had concluded, we can measure the difference and see if there actually was an impact on the speed of the runners. Can a new herbal remedy reduce the severity of a cold? Let's see, so we want to test a drug. So this would be a great opportunity for a double-blind experiment. In a double-blind experiment, a third party is going to break up all the experimentees into two different groups, give them the new medicine versus old medicine, and then another person is going to measure the impact of the cold medicine on whether it may help them be healthier or not. Okay, a margin of error. Margin of error is used to describe a confidence interval that is likely to contain the true population parameter. So it's when we collect the sample data, we're going to say, we're going to have some sort of confidence measure that says I want to be 95% confident or 90% confident. And we're going to come up with a number that's around that sample statistic. So let me kind of go back here. So our confidence interval is our sample statistic plus or minus the margin of error. So the margin of error is a number defined by a confidence level and sample size. Now in a normal statistics class, they actually go through formulas that will calculate out. So they'll give you a confidence level and a sample size, and they'll have you actually figure out what the confidence level is on your own, or the margin of error is on your own. But for us, we're just going to look at what the confidence interval measures. So an election eve poll finds that 52% of the surveyed voters plan to vote for Smith. She needs a majority more than 50 to win without runoff. The margin of error is 3%. Will she win? Well, the sample statistic is 52%, and the margin of error, so based on sample size and confidence level, we get a plus or minus 3%. So let's just do the math on that. 52 minus 3 and 52 plus 3. So 52 minus 3 is 49, and 52 plus 3 is 55. So her likelihood of winning is somewhere between 49% and 55%. Now, the way margin of error works and the way confidence levels work is if I'm curious about whether or not it's higher than 50, if 50 shows up in that interval, then statistically I can't say it's any different. In other words, maybe sample size was not large enough to justify a better conclusion, but because 50% is in there, that means the population could be in support of that. 49 is in there as well. So anyways, I don't know if it's 49, 50, 51, 52. I don't have enough information, or I don't have enough to say that it's clearly bigger than 50. So because 50 is in there, then I can't say that she will win for sure. It's too close to call at this particular moment.